we're going through the answers for the lesson 4, and you can find this as the PDF in lesson 4, but it's also on page 41 of your book, so you can write the correct answer there. If you haven't done lesson 4 yourself already, you need to stop this video now and go back and do it. What I'm going to do is I'm going to go through 4 common answers that people sent me, the people who are really good and sent me their answers, and obviously a lot of them are wrong. If you don't attempt it yourself or haven't attempted yourself and you just go and watch the video, there's a chance and a risk that you may remember the wrong way of doing something as opposed to the right way, because you're spending just as much time on the wrong answers as the right answer. So you need to go through, do it yourself, put a good 10-15 minutes in thinking about what it could be, come back and watch this video and you'll have a better chance of remembering the right way. So without further ado, let's talk about 4 different ways that people sent me to answer this question. So remember, this person throws the ball up and it comes down, and we want to look at velocities at A, B, C, D, and E. It turns out that everyone sent in, it's meant to be down, the same thing for, for velocity. Let me start that again. They sent up, they sent up, they sent 0, D was down and getting bigger. If you wanted to, you could have said, well, A's at a lower point than E. So actually A is going to be the longest arrow, not the same size as E. I wasn't too worried. If you wanted to be that looking at details, you can, sure. The main differences that I had, and the whole point of this was talking about what the acceleration is at each point, B, C, and D. So here's the 4 different ways. The first way that someone sent in was that A is going up and it's getting smaller, and then it's down to 0. So between here and here, if we were to draw our, let me change color. Our acceleration arrow, if those are velocities, velocity, velocity, my acceleration is what's between them. So my acceleration can't be this way, they've said, because that would mean that this one here is getting bigger, and it doesn't, it gets smaller. So that's wrong. So they've said the acceleration between them must be this way. And so they said at point B, the acceleration is doing that. They said at point C, because it's not moving, the acceleration is 0. For that instant, it's not moving. And they said at point D, let me get my pointer options and color my red back. Here's my velocities, they're getting bigger. And that means that between them, the acceleration, what's the difference, must be this direction, because that implies that this one gets bigger by this much to make that. That's the first answer that people had. The second answer was the same on where are we here? Was the same on the velocities, and so I'm just going to draw them in. This is the last time I'll draw these in. Everyone had the same answer for that. But they said for their accelerations, they said that on the way up, same thing, the acceleration is going down. When it's at point D, acceleration is going down, but this is the second answer. They said at point C, the velocity was here, and then the velocity becomes 0. So the velocity is still changing. And so they've said that at point C, the acceleration is also going down, and they said that they were actually meant to be all the same size. That's the second way. The third way was that because we have our velocities like this, that because it's going up at point B, the acceleration is also in this direction as well. At point C, it's not moving, and point D, it's coming back down, so its acceleration is coming down. So that's way number 3. So let's just go through these 3 answers again. We've got the first one was, I'm only really looking at the accelerations, was down, 0, down. The second was down, down, down. Third was up, 0 down. And the fourth way was exactly the same velocities. They said that at point B, the object is slowing down. So therefore the acceleration is a downwards arrow because it's slowing down. They said at point B, it's for an instant it's stopped, so there's no acceleration. And they said at point D, when the object is falling, it's speeding up. And because they got that word up in there, they think the acceleration should be up. That's the fourth way. So we've got all four different combinations of acceleration arrows. This first one with a 0 in the middle, the second one with all three accelerations pointing down, the third one with acceleration up, nothing, and then down, and the last one was acceleration down to start with, 0, and then acceleration up at the end. So the way I answered this was, if you've got your blue book in front of you and you just turn back a couple of pages, in fact just turn back one page, to page 39, there's a problem where a cart goes up a ramp. So here's the motion detector, and the cart goes up the ramp. Oh, that's upside down. What's going on there? Up the ramp, and it slows down as it gets to the top, and it gets to the top, and then it goes and speeds up again. So it goes up, and then it goes down. I see that problem as exactly the same problem as this one here, except someone's tilted the ramp like this, and here's the cart going fast, and then progressively slowing down until it gets to the highest point. And then it comes down again the other side. So this is just with a ball instead of a cart. So I see them, that problem and this problem, as identical, well, as very similar physics. Slowing down and then speeding up, slowing down and speeding up. When I did that problem on page 39 and I had my motion map, I'll change colors. There's a faster way to do this. My velocities on the, if I drew my motion map for this, my positive direction was in this way. Here's my 0. My cart got closer and closer together, and then it came down the other side, and they got further and further apart. So my velocities started off big, and they got smaller and smaller until they were 0, smaller and bigger, and getting bigger and bigger and bigger. Velocity, velocity, velocity. Which is similar to what you guys had for the velocity here. They were in one direction, they got to the top, and then they came down again. My, where are we in color? I want to go blue for acceleration. My acceleration arrows are the difference. So between here and here, it doesn't speed up, it slows down. So the acceleration must be this way. And I can do the same thing here and the same thing here. And then on the way down, the velocity is increasing. So my accelerations are still that direction. So my answer for this page, is it page 41, with my acceleration at B, my acceleration at C, and my acceleration at D, I'm pretty sure B and D are the same. I'm not sure what happens to C though. Is it 0 at that point, or is it down, or is it something else? The way you answer that, if you go back again on page 39, is to look at the graphs. You could draw, for this guy here, you could draw a velocity time graph for the ball. So we know that, I'm going to draw it up here. Here's my velocity, here's my time. The ball starts off at A going really fast, high velocity, high positive velocity. By the time it gets to C, it has 0 velocity. And then by the time it's going back down to E, it's going fast in the negative direction. This is my velocity. From my velocity time graph, I'm going to draw an acceleration time graph. Acceleration, how do we find the acceleration from this velocity time graph? It's the gradient. And if you carefully look, you'll see the gradient doesn't change. It's a constant gradient. It's a uniform gradient. It's the same everywhere. Even at this point where the velocity is 0, the gradient of the line is still negative. It's negative here, the gradient's negative here, the gradient's negative here. And the acceleration time graph looks like this. Even at this point down here, where the velocity is negative, the acceleration is not. It's still where the velocity is 0, the acceleration is still this value. So that helps me to figure out at C0. Now this is the whole point of this exercise. This part here was the whole point of this exercise. For you to learn that at an instant when velocity is 0, acceleration can equal something. Acceleration does not have to be the same thing as velocity. Okay, well done.